Hi, this is Enrico from Jarenga. In this video we will look into a setup between the AUBO i10 and the VG10 gripper from OnRobot. Let me show you the station. Okay, so basic setup, as we can see here in the video, is the AUBO i10. Don't be bothered by the i16 and the i3 there on the AGV. We are only looking at the i10 today. We use the AUBO i10 with a vacuum gripper. It's often used for palletizing and loading, unloading from conveyors to conveyors into boxes, from boxes. So the i10 is a good choice with a VG10 gripper from OnRobot. For the setup today here, we have a single-phase power line going to the station, providing power to the control box for the i10, and the compute box, which is the one which controls the gripper directly. And both of them are connected via a network cable to our network. So essentially, they are just connected like a network switch between the two, but you could also just run a direct cable from the robot control box to the compute box. Okay, let's make this small and show you the system again. Okay, and the screen. Okay, this is the teach pendant which we have seen in the picture here on the top, which is hanging there. I'm just remote logged in, so it's easier for me to capture the screen for you to have a look. Okay, let's check out the gripper first. If I find the right camera. Okay, here we go. Then I'll make a picture big for you. Okay, here we go. So the VG10 from OnRobot is an fully electrical gripper. So there is no compressed air or anything used like that. The VG10 has two channels, or here in this picture, zones, which are going through the center of the gripper. So we have an A side, which is these two suction cups plus the two arms. The arms are flexible. They can be easily rotated around the two positions with the markers. And we have a zone B on the right side here in the picture with the two arms and the suction cups. You see here the B arm is a little bit in a different angle because I just moved them by hand. So this is one of the advantages of this gripper. You can easily adjust to a different product without having to loosen any screws or anything. You just move them where you need them, and it works. The gripper is generally pretty flexible by that. Additionally, if you have some funny boxes, funny shapes, which can cause you some vacuum loss, you can put some blinds in instead of any of the suction cups we have here. So you take it out and put it in. You can change to any other standard suction cups available in the market as well. Most of them, if they follow the standard, should fit. So you can customize this gripper even further for your application. Okay, let me go back to my other screen. Okay, so here we have the robot teach pendant and the gripper. So the first thing I'm going to do is I'm going to drive. Actually, let's go through this first. Maybe it's easier. The first thing when we look at the screen to make sure that what you see in this video is actually available in the one you have. We are checking here the About button and the software version. So from version 35 up, this is what you can see here. Older versions may not have, for example, the Modbus communication in it. If you are lower in a version, you either have to upgrade, or if you have a newer version and this video is older, then it might have changed already to a certain extent. But you're going to need at least the 35 version for what you see in this video. Okay, one more step back maybe to make things easier. I make the picture big and I'll show us the station from the front. Here we go. We will have this, what I mentioned earlier, we have a compute box which is connected via Modbus TCP to the robot. We have two boxes we're going to pick up. And right now, I'm just going to drive the robot back in the start position. We can have a look at the application, and then we can go through single steps on the setup. Okay, let me make this picture. Okay, so here we go then into the program, because I manually want to drive robot to the start position. For the people who are not familiar with AUBO yet, so OBOT, like other cobots as well, has to start in the defined start position. It will automatically take the first waypoint, which is set up in the program. Here I have this waypoint, and you can see then in the picture I'm manually driving the robot to my start position right now, and then I will show more details about the gripper and some other details. Takes a moment since I have set the robot only on low speed. Okay, so we're in this position. Okay, so you saw that I pressed the Move J button. I checked the movement before. Otherwise, if you don't know the movement of a robot, it's not recommended to do it remotely like I just did. So I checked all the clearances before, just to be safe. Okay, what we're going to do first is I'm going to show under the extensions where we have a module Modbus, and normally it starts on the device config. And we will have to define the communication with the gripper. In this case, the compute box is controlling the gripper. So let me do the screen a little bit bigger for the station, and maybe I change the picture. Yeah, this was better. Okay, this is a live view of a robot we just moved. We can see the gripper here, which is connected into a quick changer. This is this plate, which is connected with a cable going down the robot to the compute box. The compute box has digital inputs, outputs. So if you have a robot or a system which is not able to communicate with Modbus TCP or Ethernet IP, it's possible to run directly with the IOs from any other PLC brand, so which makes this gripper fairly flexible. In this case, in AUBO, we can do both. We can do the digital IO or with NPN, or we do Modbus TCP. We make Modbus TCP because it makes our life easier. Okay. The one information as well, this quick changer is able to have multiple different gripper connected to that one. So the different communication is then managed by the compute box and the different control automatically. Okay, I'll make the picture smaller again, that we can go. Okay, so we see the gripper in the picture. It's not in contact with boxes yet, which will be important for a test in a bit. Okay, so here we set up. First, we created the device and then added it. We can see here we called it Compute Box because we use other grippers with this robot as well, so it's easier for us. Instead of calling it VG10, we just set up a Compute Box for communication. Because we use the quick changer on this setup, and not to do a quick changer or some force sensors or anything in between from OnRobot, we have to use the slave ID 41 for the communication with a quick exchanger to the gripper. We gave it a name, Compute Box. We set up Modbus TCP, which is Modbus RTU is for serial communication. TCP is via Ethernet adapter, so essentially your network cable. And we set up a response time of 500 milliseconds. You can do less. It will not have a big impact for the majority of the application. What's more important is the frequency of 10 Hertz, which means 10 times per second will be the communication update interval. That means every 100 milliseconds we will get the latest states, which is important. If you have high-speed application or you need to maximize the cycle time with the AUBO, for example, you can increase the frequency. However, you're going to hit a limit depending on how many IOs you are defining, so basically the data amount you're transferring, that the system may not be able to keep up with it. So we recommend, in generally, 10 Hertz is a good choice for the performance. Then we set up an IP address. In this case, this is the address for the compute box. We changed it from the standard address. The compute box comes with a default IP address with 192.168.0.1. Since we are using multiple compute boxes at the same time in a network, we are changing these IP addresses the same like the demo robots. For details how we do that, we will probably have some other videos available for the individual configuration. Okay, so the last thing which is important is the port 502, which is the default Modbus TCP port for most application. The compute box from OnRobot follows that and is also be reachable on the default port 502. Then you can just add the device, so it shows up here, and then you press connect. And if you see the screen that your connection works, if you don't see the screen, there's an error message. It can take a while though until the error message comes up because it tries the connection and has to run into the timeout first. You will get a different window, or you can always check under system info. Here's the log data in the bottom screen. There would be some red error messages related to the Modbus system. Okay, let's go back. So now we have a device and we have established communication with the compute box, but we haven't defined yet what kind of data we actually want to exchange. This is what we do under IO config. Here we have different options for registers. It depends always on different devices how to communicate. I'm not going to go too much into details here in this video. There may be another one for that. Just copy basically what we are doing here. If you try to set it up yourself, that will help you most. Okay, what do we have? So the compute box with the VG10 gripper, communication is clear. We have 2 register outputs, which means we can send information to the compute box. On the register which was under address 0 is for the channel A, which we saw earlier, to control the vacuum. And under address 1 is the channel B, which is a control for the channel B. Okay, when we want to read the vacuum, we have the channel A and channel B actual value, which are inputs, which means we are reading from them, and they are under the address 102 and 103 for this configuration. So you just configure them on the bottom, add them, and then there we are. To check what the actual state is, we go under IO state. Here we can see that the inputs are listed in the AI section, the outputs in the AO section. So AO here, this is what we send and what is in the register on the compute box. And here we can read what the compute box reads, in this case from the vacuum sensors. Okay, so how to test this right now? We go under IO control. We have here channel A, channel B, and we want to turn channel A on. This is a little bit specific here. The actual vacuum we do in percentage, so we do between 20 and 80% roughly. 20% is the minimum. There is some translation of the number we are keying in here in the background, how it is handled in the communication. So the 20% vacuum is equal to 276. I'm not going to go into details why it is that number. Just if you want to turn 20% vacuum on the channel A, we key in 276. If you want to do 21%, you just add 1 and you do 277. This is how you can control it up to 80%, which is recommended by the manufacturer. Okay, I cannot share the information or the documents where these register addresses are coming from because there's confidentiality clauses in place. However, I'm allowed to show in the videos how they are set up, so just go for the videos and it will be fine. Okay, to turn channel A on, we just send 276, and now we want to check if it actually went to the compute box, and we can see, yes, it is on 276, but we are not measuring anything significant on the channel A on the actual value. So the actual one will be the vacuum in millibar. We're not having anything. Why? If we look in the corner of a small screen, which I will make big now, we can see that we are not in contact with the surface of a box, and therefore it is correct that there is no vacuum building up. Okay, I'll make this smaller again, so we can go to the IO control and do channel B. Same thing, 276. Okay, send, check on the IO state. Okay, is there. There's no vacuum at all because we are not in contact. Okay, so these two work. Let's turn them off. Send 0, send 0. Check the IO states, they are 0. Okay, so now I'm going to drive the robot down into the pick position. I will explain my program in a bit, so don't worry too much about it now. I'm going to move linear down the robot to be in contact with the boxes. Let's have a look in detail. Okay, we can see we are in contact. Maybe we are hitting a little bit the edge. Let's see if we are building up vacuum properly or not. Okay, going back to the Modbus control, IO control, the channels. I'm sending 276 again. Send, second channel 276. Okay, send. check the I/O state, and so we see we can actually have a vacuum pressure in millibar right now because we are in contact. Let's have a look at the bigger screen. We can see a little bit of lift on the boxes. When I run the program, it will be more obvious here. Okay, let's go back. So this works. I will turn them off, and then I'll go and explain a little bit more about the quick program I did there. Demo. Okay. So programming, if you're not familiar with AUBO, there will be other videos how to program step by step. I'm not going to go through all the details right now because that's not the point of this video. Okay, let's go through what I actually did here. So as a general rule, I'm using quite a couple of block comments. It's essentially as a folder where you can change the name and a comment that makes it more readable for other people if you're not working alone on the robot, or if you're coming back after a couple of months or years and try to understand what you actually did there. So I recommend that to use. So whenever you see here on the top part the block comment, it doesn't do anything, just be a collection of items in it. It's very helpful when you forget things within your program and you want to move something into a loop or an if or an else. If you don't use block comments, you have to move everything one by one, and it can get a little bit annoying. So I highly recommend to use them. So what I did here, the other beauty is that you can also just hide stuff temporarily, which makes your area you're working with more readable. Okay, what did I do here? So generally I do one block initialization, and then I have a main loop, which is my main execution of a program. On initialization, I put normally things which are helpful for the application. I'll make sure that the state of the application which we will run or start is defined. So in this case, what I did is I use the set condition, which can control outputs of any kinds of forms. I use it to control the Modbus area here, and then channel A, and I set it to 0, which is the release of a box. So I just make sure that the channels are off, channel A and then channel B. Then I have a move which has a waypoint in it. This move doesn't really matter much except for one fact: it holds my first waypoint of a program, so that's the start position. Here I just changed the name of a waypoint, and these are the coordinates. When we start the program, I will manually have to drive a robot to that position, so when it actually executes the program, it doesn't do anything on its move because it's already in that position. The next step is an if never. So basically I wanted to have a waypoint for you earlier to see at the beginning the suction cup and the setup, so I just put it in here with a waypoint which I manually can move to. It will never be executed because I just put a condition in it if one is 0, which is never true, just so I can put it there without having to manually move a robot, which would have taken much longer, just to save time. Okay. Then we have a main loop where I decided I execute it 4 times. I can always loop them, or I can make a loop condition like an external button, an input, or a sensor from the conveyor, or anything like that, or PLC signal, whatever we would like to have there. Then I made a pick and place block comment again, and I have a move, and my move is essentially going down to the position in contact with the boxes you saw me earlier driving to this point, and you can see in the picture right now that it is in touch. This is the pick position. Okay, it's also the place position, because for the demo I just move up and down and place it in that position. Okay, so what did I do next? This is the one which is a little bit trickier, but it's just for people who are not familiar with the programming. It's just that I'm generally a little bit lazy. So what I did here is I have an if condition which is checking if my channel A and B are both off. That means I come to the down position and they are off. That means I want to pick something up. If they are on, I know I'm carrying something and I want to place something, and then the else condition will be executed. So this means if my vacuum is off, I want to turn on the first channel. We see here the 276 again, which we have done on a manual test. Then I'm waiting until our input is at least 200 for the actual vacuum. Then I'm turning B on, again with the 276, and then I wait until I get the actual vacuum. And then it's going to go to a move and just in a position which is higher in the air, just so we can see that it carries the boxes around. Okay, so this would be loop number 1. So go to the bottom position, turn both channels on because they were not on, go up to the lift position. Now we are coming back to the loop, which means go down again. This time the vacuum is on because we are carrying the boxes, which means it executes the else condition. And in the else condition, we are doing a release, so we set the channel A to 0. And then we wait until the vacuum is 0. Channel B to 0, wait until the vacuum is 0. And then we lift up again. So this is the round number 2 in the loop. Number 3 is pick up again, and number 4 is place again. So let's run this in the video with a small screen first, and then I'm going to do it on a big screen. So right now we are in touch, the vacuum is off. So when I press start on the robot, we are not in the position where we need to be. It's not the first position in the program, so I manually have to drive a robot to this position. Once it's in this position, I can actually start the program. Okay. Moving down, picking up both boxes. Maybe you can see in a small window, we pick up one first and then the second. Don't mind the boxing hopping a little bit. There is basically no weight in these boxes right now for this test because I just used some of the quick changer boxes. As soon as there's some weight and they don't do that, the reason here is the suction cups are that good that they still stick a little bit after that. This case is also because this is coated carton. If you have a normal, more porous carton, it's also going to behave differently, and you are not going to be able to do it with 20% vacuum. You will have to go to a higher ratio. Okay, I'll make the screen a little bit bigger for you again, and then I run the application right now again in the background. I have to manually jog the robot to the start position because my lift position where it stopped was higher than this one. And then I'm starting the program. Okay, so first channel, second channel, and then second loop we are placing these. Okay, now we are picking up again, and we are placing it. Okay, channel A, channel B, and then we are done. So that's pretty much most of the information about this one. So additionally, so this gripper can be used for obviously the i16 and the i5 and so on. For very flexible application. We use them mostly with the i10 for anything palletizing because we either need the reach or we need the payload. If you need a higher payload in an application, you can use the i16, for example, and the bigger brother of the VG10 is the VGP20, which can handle 20 kilogram, and another advantage is it actually has 4 channels and not only 2. So if you have applications which need to be even more flexible, there's also an alternative for that. Okay, that's for this video, and we will have more videos available.